For this video, we are going to continue looking at evaluating the 6 basic trig functions. But in this video, we're going to be given some information and then we need to kind of fill in the rest. So when we take a look at this, so this one is telling us that the sine of theta is 3/5, and then we want to find the rest of the trig functions. So what I suggest is creating a right triangle and then filling in what you know. So in the future, like near future, like next video, we are going to be kind of looking at triangles in the XY axis. So you'll see that I'll draw mine pretty much like this all the time because eventually we're going to be drawing them from the origin here and then down to the positive x-axis. So I just draw mine kind of with the angle in, I don't know, right here, so that it could be at the origin. So if you want to start trying to do that, it will probably be helpful in the next few lessons. So then what I do is I put theta here, right, kind of at the center, because it'll be at the center here. So now for sine, remember that sine is opposite over hypotenuse. Okay, and it doesn't matter if you draw your triangle differently. I'm just trying to give you a heads up. But so I just put theta here. Opposite side would be here, so that's going to be 3. And then the hypotenuse is across from the 90-degree angle, so that's going to be a 5 right there. So in order to make this very much like our last video, we just need to find this missing piece here. Then we can just quickly fill in the 6 trig functions. So you may remember this triangle as one of the most used or most common Pythagorean triples, and just automatically know that that's a 4 for a 3, 4, 5 triangle. If you do, that's great. You can totally use it. If you don't remember that, then you would just do a simple Pythagorean theorem quickly here. So c squared, so 5 squared equals that missing side squared plus the other side squared, the 3. So then this is 25 equals x squared plus 9. Subtract the 9 from both sides, and then square root to get that 4. So now you just need to fill in all of the 6 trig functions. So we've got cosine of theta that we'll find, and with cosine goes secant, the reciprocal of it, and then we have the sine of theta that we'll look for. The reciprocal of that is cosecant, and then we have tangent, and then we have cotangent. So we were actually given the sine already, right? That one was given to us at 3/5, so I'm just going to steal that to plug in. Then for cosine, cosine is the adjacent. Adjacent to the theta is the 4 over the hypotenuse, which is 5. Flip that for secant, so 5/4. Sine was given to us as 3/5, so cosecant is the flip of that, 5/3. Tangent is opposite over adjacent. So the opposite of theta is 3. The adjacent to theta is 4. Cotangent would be the flip of that. So if you can get this triangle drawn with the given information, it's pretty simple. It's just like the last video. So for this one, cosine, so again, I'm going to draw the triangle. And it doesn't matter if you draw it like to scale. So this one's not going to, I mean, maybe it is, maybe it isn't. I mean, by the lengths of these, just draw a right triangle. And then label it. So I'm going to put theta right here. And then cosine is adjacent over hypotenuse. So adjacent to this theta would be this one here at 7. Hypotenuse would be across from the 90. That one's going to be the 10. So then we need to find this missing leg. So we will again do the Pythagorean theorem. So 10 squared is 100. 7 squared is 49, plus this missing length. Now I'm going to call it y. Again, that's for an upcoming. So after this, when we start putting them in the coordinate system, then this length will be the x, because that's the x distance, and then this will be the y, because that's the y distance. So whenever I'm looking for the height, I'm just going to call it a y. So then we'll subtract 49 from both sides and get 51 equals y squared. square root that, and you get that height there. So then just fill in your 6 basic trig functions. You have cosine, secant, secant, sine, cosecant, tangent, and cotangent. So cosine was given to us at 7/10. Flip that for secant, so 10/7. Sine, opposite side, which is square root 51, over hypotenuse, which is 10. So flip that and you get 10 over square root 51. If you were you could rationalize these. So if it's asking you to rationalize your denominators, then you would want to multiply both top and bottom here by square root 51. So let me just show you how that would look here. So then the top would end up becoming 10 square root 51, and then the bottom is going to be just a plain 51, because you're going to get 51 times 51, which is 51 squared, and then those would cancel, so you just get over 51. And then if these two could simplify, you could, but 10 and 51 don't have any common factors. So then this would be the rationalized answer. So if you have to do that. And then tangent is going to be opposite, which is square root 51, over adjacent, which is 7. So over here, we would flip it to 7 over square root 51. And then again, you could rationalize it. So it would be square root 51 over square root 51. So you'd get 7 square root 51 over just 51 for the rationalized version of that. Cotangent. So remember, tangent is, tangent is opposite over adjacent. So cotangent is adjacent over opposite. So we'll put theta in here. The adjacent side is 6. The opposite side is 5. So then we would need to find the hypotenuse by doing the Pythagorean Theorem. So we'd have 6 squared plus 5 squared. So 36 plus 25, which is 41. So this will be square root 41. And then again, just filling in all of these. So cosine, and cosine is going to be adjacent over hypotenuse. So 6 over square root 41. Rationalized version of that, multiply square root 41 over square root 41. So 6 square root 41 over 41. Secant would then be the flip. Now I wouldn't flip the rationalized version, because here you're just going to flip it over. So then you'll get the square root on top and you won't have a square root on bottom. If you were to flip this, all of a sudden, okay, if you flip it, you're going to be at 41 over 6 root 41. So now you just put a radical in the denominator. So I would just flip from the original. So then sine of theta is going to be opposite over hypotenuse. So again, if you need to rationalize, that's going to be 5 square root 41 over 41. Cosecant theta, flip the original, so square root 41 over 5. Tangent of theta, opposite is 5, adjacent is 6. Cotangent, flip that. Cosecant. So remember, cosecant is the reciprocal of the sine function, and sine is equal to opposite over hypotenuse. So this is going to be hypotenuse over opposite. So I'm going to put theta here. Hypotenuse is going to be this one. Opposite is here. Pythagorean theorem, so you'd do 3 squared equals x squared plus 2 squared, which is 4. Subtract 4. And then square root. So then again, cosine is going to be adjacent over hypotenuse. So the adjacent side over the hypotenuse. So then secant is going to be 3 over root 5, or rationalized is going to be 3 root 5 over 5. Sine is going to be the opposite over the hypotenuse. So cosecant, which we were given, is going to be the flip of that, 3 over 2. Tangent is going to be opposite over adjacent, or the rationalized version would be 2 square root 5 over 5. Cotangent is going to be the flip, again, flip the original so that the radical is on top. And that's it.